Hey guys, we are going to move on to lesson 1.4 where we start talking about experimental design. So I'm just going to get you through a couple slides here, some new vocab. I have a short 5 question activity for you to try today, and I will be back tomorrow so we can go over anything we need to clear up any confusion and hopefully kind of pick up where we left off. So we're going to start talking about experimental design. So here's a little intro for you. Proper study design ensures the production of reliable, accurate data to help us make good, informed decisions. A flawed process leads to a questionable decision. So basically, we want to design our experiments to get the results that we want. That's what reliable means. We're measuring what we're supposed to be. And accurate data, meaning, our variables are accurately being measured, so our data makes sense. And if we have accurate data, we can make better decisions with our statistics. Even if you have never Even if you never have to design a study yourself, you will likely have to look at and interpret the results of one. Before interpreting the results, you should determine if the results are reliable. So again, just kind of a lot of vocab that goes along with this. So we're going to dive into that right away so we can kind of understand this experiment design and studies and all that good stuff. Okay, let's start with observational study and experiment and the difference between the two because they are actually like pretty different. So observational study is a study in which individuals are observed or certain outcomes are measured. No attempt is made to affect the outcome. Okay, so it's kind of what it sounds like. You're just observing. So let's say you're observing traffic patterns. You would just be out in the streets watching the traffic flow, the lights, but you're not changing anything. You're not trying to put a new stop sign in to see if that can control or slow down or make this flow of traffic more efficient, anything like that. You're not adding anything in. You're just observing and looking for outcomes just based upon the environment itself. You're not changing anything at all. That's an observational study. An experiment, on the other hand, is a study where researchers apply a treatment and study the effects. So now we're actually changing things. If I wanted to figure out what type of fertilizer best makes a certain plant grow, I would be changing and testing out different types of fertilizers and like manipulating that myself. And that's an experiment. You might have heard these vocab words before in science class, or even maybe you talk about them in AP stats. But so we're actually um, applying a treatment. We'll break down treatment in a second here. Basically, anything that's done in an experiment and study the effects from changing things ourselves. Okay, so we have just observing and then experiment where it's more hands-on and manipulative. Okay, next. So the reason why we do these experiments is we want to investigate relationship between variables. And a lot of times we're looking for like a cause and effect relationship. Like, does the amount of soda one person drink cause them to gain weight? Something like that. So we have some different types of variables. The first one is an explanatory variable. So this is a variable that causes change in another. Now, you probably have more heard the terminology like independent and dependent variable, especially like in science. This would be your independent variable. Independent. It can also be called the predictive variable. But in statistics, we call the explanatory variable. Okay, so then the response variable is the variable affected by the explanatory variable. So this one would be your dependent variable. So let me give you an example here with these two. Say you are experimenting if the time of day determines how many cars are on the road or like the number of cars on the road. Does the time of day affect how many cars are on the road? So your explanatory variable would be the time. That's what's using to predict the number of cars. And the number of cars would be your response variable or your dependent variable. Does the time affect how many cars are on the road? My third one here, confounding variable. This would be a variable that influences both the explanatory and response variable that is not accounted for. So these would just be like some extra variables that kind of come up during the experiment that we didn't really like intend to. So going back to my car example, say like a car accident happened right in the middle of our experiment and it caused a big traffic jam. This would be another variable that we weren't intending on happening or affecting our study, but it did. It came up. These are also called lurking variables. So if you ever see that vocab or that word usage, just know that means the same as confounding variable. Okay, couple more. Experimental units. So experimental units are who or what the treatment is imposed on in our experiment. So this could be a person, animal, could be a plant, etc. And then our treatment is what is done or not done to experimental units. So let me give you a quick example with this. Let's say I want to test different cake pans. Let's say I have like aluminum, glass, and plastic are my three options, and I want to see which type of cake pan cooks the cake the most thoroughly, gives it the most like moist feel. I don't know. The experimental units, who or what the treatment is imposed on, so what we're actually experimenting with would be like the cake batter. That's where we are changing the pan type, and the cake batter is what the treatment's actually being like applied to. So the treatment in that case would be the cake pans, the different cake pans. Okay, so there's just a little example of those. So we're going to take a break from the notes and I'm going to have you guys do just the front page of this handout here that's titled, Does SAT Prep Improve Scores? So just to read through this really quick for you, last year EKHS offered an after-school SAT prep class that students could volunteer to take. 44 students took the course and then took the SAT. The average SAT score for this group was 1220. The average SAT score for all students who did not take the prep class was 1050. Okay, so I just want you guys to go through these 5 questions. You can either do this in small groups, or if you guys want to kind of talk about it like as a whole class, I'm fine with that too. You don't have to move on to the back page. Let's save that for when I get back tomorrow. But this just kind of goes over some of the vocab we just talked about. So you'll see number 1 there, observational study or experiment. Number 2, see if you can identify the explanatory and response variable. 3, can you determine cause and effect type of relationship here? 4, what are some other variables? This would kind of be like the confounding variable we talked about. And then 5, design an experiment that would allow us to determine if the SAT prep causes an increase in SAT scores. Be as thorough as possible. That one might be a little bit of a challenge, but I just want you guys to get talking about this and try it together. And then when we come back together tomorrow, we can talk over this, like I said. So if you get a little stuck, don't get too discouraged. Just give it a good try and get talking about some statistics. All right, I'll see you guys soon. Good luck.